All right, good evening, geometry students. Today we're going to continue our discussion of the trigonometric ratios, but today we're going to take a little bit deeper look at the math that is involved with those and the things that they can actually do when pieces of information are missing. So let's take a look. Our objective for the day is to apply the trigonometric ratios in order to solve for missing side lengths. Again, I do not know what date these notes will be in class. I'm sure you can fill it in as class gets a little closer. Copy down your objective, leave you a space for the date, press pause anytime you need more time to copy stuff down, and then hit play when you're ready to move on. Okay, so let's have a look. As we said last time, there were 3 rules that we needed to remember, and the word we needed to remember them was, well, what was the magical 9-letter word? It was SOHCAHTOA, S-O-H-C-A-H-T-O-A. And we said we needed to remember that in including the correct spelling, because all 9 of these letters mean something, and they also mean something as far as the order that we use them. There's some fractions involved in there, and if we get our letters out of order, that can cause us to mess up our fractions, get things upside down, stuff like that. Okay, so the order, S-O-H-C-O-H-T-O-A, basically translated into the sine of theta equal the opposite side over the hypotenuse, the cosine of theta equal the adjacent side over the hypotenuse, and tangent of theta represented the opposite side over the adjacent. Up until now, all we have done is worked with these 3 in order to identify the different ratios inside of the triangle. Okay, but today we're going to use those ratios, and we're also going to use our acute angles theta in order to figure out missing side lengths. Uh-oh, something just happened there. Okay. All right, so those apply to any acute angle theta in any right triangle. And today we're going to use known angle measurements in the triangle in order to find unknown side lengths. That'll be something that's a little bit different from us. To this point, we have used sides to find other sides. We've used angles to find other angles. Now we're going to kind of cross that barrier and start using angles to find sides. And then tomorrow we'll be using sides to find angles. So let's take a look at how it works. Here we have a right triangle. That's important to note because once again, we never ever use sine, cosine, or tangent unless we are certain that we have a right triangle. Okay, so we do have a right triangle. We can see that we have some angle information, we have some side information, and we are missing a side, and we're supposed to solve for it. So let's have a look at what's going on in this triangle. Okay, we have 3 rules: sine, cosine, tangent. Okay, which of the rules should we use? Well, the answer is going to kind of depend upon what information we actually have in the triangle. Okay, we need an acute angle to work from. Okay, we need an acute angle to work from. And as we know in our trig functions, there are 3 unknowns. There's an angle measurement, theta, which is unknown, and there are 2 side lengths, depending on which ratio we pick. The 2 side lengths are unknown. Okay, so we have to select the one that most suits, okay, the type of problem we have. Obviously, we are missing a side length. Okay, so obviously that is unknown. That means that our other 2 pieces of information that we select need to be pieces of information that we do know. We are going to need an angle measurement to go along with this, and we're going to need another side to go along with this. So obviously, we have the opposite side. If we use 25 degrees as our theta, then our opposite side would be x. Okay, so we're going to pick a formula that uses opposite. And what is the other side length that we actually have in the problem? We have the hypotenuse. So we want a ratio that will talk to us about opposite and hypotenuse at the same time. So think about your word, SOHCAHTOA. Where do you have opposite and hypotenuse in the same grouping together? That would be the sine function. The sine function is opposite over hypotenuse. Okay, that's important. It's a very important decision to get to. That's why we spent so much time talking about it, because if you pick the wrong trig function, you will not get the right answer. Okay, so we're going to use the sine function. So let's do that. The rule says sine theta equals opposite over hypotenuse. So let's plug in our values where they go in our formula here. Theta, we have 25 degrees. Okay, our opposite side is our variable x, and the hypotenuse is 10. Okay, well, just like any other problem, we are going to solve for our missing variable. Right now, our x is sitting on the right side of the problem. Excuse me, but but the problem is that x is not alone. X is being divided by 10. So I want to get x by itself. So how do I undo x being divided by 10? Well, what's the opposite of divide by 10? Obviously, the opposite would be to multiply both sides by 10. On the right side, that's going to cause a 10 in the numerator, a 10 in the denominator. Those are going to cancel. And what we have on the right, or the left side, pardon me, is just a number. Okay? We have 10 times sine of 25 degrees. Now, sine is a mathematical operation. Okay, it's just like anything else, like addition, subtraction, multiplication, division, squares, square roots. It's an operator. It is doing something in the problem. Now, we're not going to be so worried about what it is doing. We're simply going to say, you know what, it's a number, okay, and Mr. Hill's not making you know what kind of math is actually going on with that number, so I'm going to let you go to your calculator on this one. Okay, but there is only one catch. Okay, you need to make sure that your calculator is in the correct mode. So we're going to take a second and we're going to look at our calculator so you can make sure you'll know how to make sure it's in the right mode. Okay, for the TI-80 series calculator, what you're going to do is you're going to go into the mode menu. Okay, in the mode menu, there is the third line right there. Okay, and the default position for the calculator is actually on the very left-hand side where you can see it says radian. If the calculator's memory is cleared, it will go back to saying radian. Well, actually, there are different ways of measuring angle measurements. Okay, we work in degrees, but that's not the only way angles can be measured. There's other measurements called radians or gradients, and there's just different ways of labeling angles. Okay, we're working in degrees, so we need to make sure the calculator knows we are in degrees. So if your calculator's not in degree mode, you need to set it to degree mode, and that also goes for other types of calculators. I know some of you have some other types of graphing calculators, other types of scientific calculators, and that's fine. Just make sure your calculator is in degree mode as well. Okay, then all you have to do is just type it up. You've got 10 times sine of 25. So when you type it in your calculator, 10 times sine 25, we're going to get a decimal point. Okay. Now I'm going to ask you to give me at least a couple of decimal points on that. That does not mean that you need to copy down this 9-digit decimal point or anything, but we are certainly not rounding off to the nearest whole number or anything, you know, elementary school like that. Get at least a couple of decimal points. Round it to the hundredths place. That is fine. So the length of x is in the ballpark of 4.23. Okay, let's take a look at another one. Shouldn't take us nearly as long to go through this one. We have a triangle. Before we consider doing any trigonometry with this triangle, we need to make sure that we are actually looking at a right triangle, because remember the trig only works in right triangles. So we do have a right triangle. That's good. So we can use trigonometry. Okay, so once again, the question will become, all right, we can use trigonometry, but which ratio should we use? Well, we are in need this time of the hypotenuse, and we are provided with the adjacent side. Okay, so we're going to ask ourselves, all right, which trig function will use hypotenuse and adjacent at the same time? So think of SOHCAHTOA, okay, and find the one ratio that does adjacent and hypotenuse at the same time. That one would be cosine. Okay, so the cosine ratio is the one that is going to help us out this time. The cosine rule says cosine of theta equals adjacent over hypotenuse. Now, obviously, we have an acute angle, 32, that we are working from, so that's going to be our theta. Our adjacent this time, which one will it be, the 12 or the y? It's going to be the 12 this time, and the hypotenuse will be the y. Okay, so when we plug in our values, here's what we have. Now, this one brings a little bit of a different problem into play. And the problem right off the bat is this. Our variable is in the denominator. Now, we will never be able to work this as long as our variable remains in the denominator. So we ought to get that thing out of there at the very first opportunity that we have. Okay, so I'm going to move it right now. And the way that you move it is to multiply it. It was in the denominator because it was dividing. It was dividing by y. So we're going to multiply the y out of there. And of course, whatever we do to one side, we do to the other. Okay. Now that's going to put y over on the left-hand side. And that did not isolate y, but it did get it out of the denominator. That's an important step. Okay. Now, what happens next? Well, as I said, these trig functions and their angle measurement, it's just a math operation. It's just a number. Cosine of 32 degrees is just a number. Okay, so what is happening on the left is our variable y is being multiplied by this number, cosine of 32. So how would we move any other number if we wanted to get it away from y? Okay, well, it's multiplying times our y. The opposite of multiplication would be to divide it. So we are going to divide both sides of the equation by cosine 32 degrees. On the left side, the cosine 32s are going to cancel, leaving just y. And on the right side, we would simply go to our calculator and say, hey, calculator, what is 12 divided by cosine 32? Now, if your calculator is already set up, it should still be in degree mode. It shouldn't kick itself back out of degree mode or anything like that. But always check your calculator. Make sure you're in degree mode. If you don't, you will get a strange answer. Okay, and the calculator in this case, when we go to it and say, all right, calculator, what is 12 divided by cosine 32? The answer should be, rounded off to the nearest hundredth, 14.15. It's not that difficult. It's just a different type of problem than we're used to seeing. Okay, now I believe I have a couple of examples here for you. I want you to copy down this triangle. I want you to select an appropriate ratio, one that can use this 2 and this x as side links. Set up your ratio and see if you can solve it. Now, I understand not everybody has a TI-80 series graphing calculator at home. However, if you have a computer, the calculator that is built into your computer should have trig ratios into it. You may have to, on the calculator setup, make it go from just like a standard calculator to a scientific calculator, but you will find sine, cosine, and tangent in there. Every scientific calculator in the world has sine, cosine, and tangent. And of course, you can stop by the room in the morning, finish off your calculations if you need to. Okay, so there's that one. Select the appropriate ratio and work it out. And then I have a second triangle for you as well. Copy this one down. Look at the side links that you're provided on this one. Figure out which ratio would be appropriate. Set it up and see if you can solve for y. I appreciate you finding time to get your notes done. Also, take a little time, solve those two triangles before you come to class. And I will see you when you do come to class.